In this video, we will see the most widely used inductive transducer, linear variable differential transformer. So, based on the previous understanding that we went through, the self-inductance and mutual inductance mainly depends on the permeability of the movable iron core and the reluctance, the path that exists between the moving plate and the current carrying coil that produces the flux lines, okay, the source. Okay, so the so here what you have a soft iron core that is placed between the primary and the secondary windings. So when they are placed between the primary and secondary windings, what happens is I have an alternating current, I have an alternating EMF, I have an EMF produced across it, and because of the changing in the EMF, there is a current flowing in the coil, and when the current flowing in the coil changes, there is a change in the flux lines producing it, and it induces an equal magnetic, it induces an EMF in S1 and S2, and this EMF in S1 and S2 can be seen as ES1 and ES2. So the change in the primary coil induces an EMF in S1 and S2 are given by ES1 and ES2, and these are connected in the series opposition. Once if you connect in series opposition, what happens is at null position, that is this position, there is an equal EMF getting induced in ES1. Why is that getting induced? Due to change in permeability and reluctance, right? So that is getting changed, that gets induced in S1 and S2, which is given as ES1 minus ES2. So in null position, both are getting equal EMF, that results in 0. Okay, but usually that will not be in 0 because of baseline drift. This is one of the characteristics that you remember we would have discussed in the unit number 1. Okay, and you can always remove the baseline drift by taking the mean of the values and then subtracting it the values. It will just go down to the 0 value. Okay, so at 0 position, equal EMF gets induced. At core at A position, what happens? ES1 is more, so ES1 minus ES2 will be your output. At core, when the core is moving to that side, it will be ES2 minus ES1. So more EMF will be induced in the secondary coil of ES2, and based on that, you will have an output something like this. And this residual voltage will always be that which is easy to be removed. What are the advantages of LVDT? The LVDT has a very good linearity of 0.05%, infinite resolution. It can go to a smallest fine resolution of 10 power minus 3 mm. That is a very good resolution. That is 10 power minus 6 of a meter. That is micrometer also it can measure. High output, there is no need of any amplification. It gives a very good output. High sensitivity, 40 volt per mm. So per every mm it gives a 40 volt change. Ruggedness, it can tolerate shock and vibrations. Less friction, low hysteresis, it returns to the same condition after the unloading effects. Power consumption is also less. So what are some of the disadvantages? The related laws are required for appreciable differential output. You saw that 40 volt per mm. They are sensitive to stray magnetic field, but shielding is also possible. Many times transducer performance is affected by vibrations, and receiving instrument must be selected to operate on AC signals or demodulated network. So there are also effects of temperature. At LVDT, it's used in a wide range of applications in the industrial. For as far as biomedical application is concerned, the can be used for understanding. So it can be used for displacements of limbs in. It can be used to study the displacement of limbs in biomechanical studies. So that's one of the applications in biomedical standards. So these until now, all this we have read about inductive transducers and their changes. So these are the sets of inductive transducers, and most widely of them is LVDT. Thank you.